All right, let's take a deep dive into some fascinating new research in the world of large language models, or LLMs as they're called.
Okay.
Um, we've got this paper here from Google. It's called Efficient Infinite Context Transformers with Infini-attention.
Okay.
And it's really tackling a challenge that I think has the whole AI community buzzing right now.
Yeah.
You know how LLMs have a limited memory when they're processing text?
Yeah, that's the context window.
Right.
A fixed limit on how much information they can really consider at once.
Exactly. And that's a major bottleneck. But imagine if we could break through that barrier.
Right.
This paper is suggesting a way to make LLMs process practically limitless text,
Wow.
which opens up some pretty wild possibilities.
It's an ambitious goal, for sure. I
Yeah.
mean, the current LLMs, they really struggle to remember information from, say, the beginning of a text when they get to the end,
Mm.
especially as the text gets longer and longer.
Exactly. And that's where this new thing comes in that they're calling Infini-attention. It's this mechanism that's designed to overcome that limitation and give LLMs a much broader perspective.
Yeah.
But before we get into like the nitty-gritty of how it works,
Okay.
maybe we should take a step back and just talk about the problem itself.
Sure.
What's so difficult about getting LLMs to handle these really long sequences of text?
Well, the core challenge is really in how these models process information.
Okay.
They use this mechanism called attention
Right.
to focus on different parts of the input text and understand the relationships between the words and sentences. Think of it like reading a book and highlighting the important parts.
Okay, so the LLM is like actively paying attention to the text as it's processing it.
That's a great way to put it.
Okay.
But here's the catch. The more an LLM has to highlight, the more computationally demanding it becomes.
Ah, okay.
The memory requirements go way up because it needs to store all those relationships, and the whole system can slow to a crawl.
So it's like trying to juggle too many things at once and eventually you
Yes.
drop something.
Exactly. Traditional attention mechanisms, they struggle with this. Just to give you an idea, a large language model with, say, 500 billion parameters and a context window of 2048 tokens could require 3 terabytes of memory,
Wow.
just for its key value states,
Terabytes.
which are basically the building blocks of its memory.
That's a crazy amount of data.
It is.
No wonder it's so difficult to scale these models up.
Yeah, it's a major hurdle. So to address this, the efficient infinite context transformers with Infini-attention paper
Right.
is proposing a completely new approach.
Okay, so how does Infini-attention actually work?
What?
Does it just throw more memory at the problem?
It's actually much more clever than that.
Okay.
Instead of just increasing the memory, Infini-attention combines the strengths of 2 different approaches. It uses local attention, which is very effective at processing small chunks of text in detail.
Okay.
And it combines that with a compressive memory system, which is excellent at storing information efficiently over longer periods.
So it's like having a short-term memory for immediate processing and then a long-term memory for storing the bigger picture.
You got it.
Okay.
That's an excellent analogy. It's like having a notepad for your immediate thoughts,
Right.
but then also having a filing cabinet to store the detailed records.
Makes sense. So walk me through how this actually works step by step.
Okay.
Let's say we're feeding the LLM a really long document.
All right, so first, Infini-attention breaks the text down into these smaller chunks, much like chapters in a book.
Okay.
Within each chunk, it uses traditional dot product attention to analyze the relationships between words and capture that local context.
Okay.
But here's where things get interesting. Instead of discarding the information from previous chunks, it stores a condensed representation of it in its compressive memory.
Ah, so it's not just processing the current chunk in isolation. It's remembering what it's read before.
Exactly. Think of it like taking notes. It's condensing the key information from each chunk
Okay.
and storing it in a way that's both efficient and easily retrievable.
Oh.
Then, as it moves to the next chunk, it can refer back to those notes to maintain a connection to the broader context.
It's like a student constantly cross-referencing their notes as they're reading a textbook.
Precisely. And to make sure it doesn't get bogged down by too much information from the past, it uses something called a gating mechanism.
A gating mechanism.
What's that? Think of it as a control valve.
Okay.
It decides how much weight to give to the information retrieved from memory versus the current local context.
Oh,
It's learning to balance the importance of recent details with the broader context.
fascinating. So it's not just blindly storing everything, it's learning to prioritize and focus.
Right.
Okay.
And this is really what makes Infini-attention so efficient. It can handle incredibly long sequences of text without needing a crazy amount of memory.
So how does this approach compared to other models that are designed for long sequences.
Okay.
We've got things like Transformer XL, the compressive transformer, the memorizing transformer.
You're right. There are several other models out there that are trying to tackle this problem. Yeah.
However, those models typically require more memory as the length of the sequence increases.
So even with those advanced models, we're still hitting a ceiling
Yeah,
with the memory.
exactly. But Infini-attention takes a different approach.
Yeah.
Because it uses this compressive memory system, its memory requirements stay relatively stable even as the text gets longer.
So it's like having a really efficient filing system
Yeah,
that allows you to store tons of information
exactly.
without losing those details.
That's it.
Okay. So Infini-attention seems really promising in theory. But does it actually deliver the goods in practice? Does it perform well on, like, real-world tasks?
That's the real test, right?
Yeah.
And that's where this research gets really exciting. They put Infini-attention through a battery of tests,
Okay.
and the results are pretty impressive.
All right, I'm on the edge of my seat. Tell me more.
Okay, so they started by testing Infini-attention on this classic task in language modeling,
Okay.
where the model has to predict the next word in a sequence.
Right. They use these data sets called PG19 and math, which are known for containing super long and complex texts.
So PG-19, that's based on books, right?
Yeah.
And math, well, that just sounds intense.
It is.
Are those good tests for a model's ability to handle those long-range dependencies?
Absolutely. They're perfect for this kind of evaluation.
Yeah.
And the results were promising. On PG19, the Infini transformer achieved a perplexity score of 9.65.
Now, remind me, what does perplexity measure again?
Perplexity is basically a measure of how well the model predicts the next word in a sequence.
Right.
The lower the perplexity score, the better the model's performance.
Got it. So lower is better.
Yeah.
So 9.65 is pretty good then.
It's very good.
Yeah.
Especially when you compare it to other models.
Okay.
The memorizing transformer, which is specifically designed for long sequences, achieved a perplexity of 11.37 on the same data set. And remember, Infini-attention did this while using significantly less memory.
That's impressive. So it's not just about cramming more information into the model.
Right.
It's about processing it efficiently.
Exactly.
Did they only use one configuration of Infini-attention for these tests?
Actually, they experimented with two different update rules for the memory component,
Cool.
linear and linear plus delta.
I'm curious about this linear plus delta rule. What's the delta part all about?
So the delta refers to a mechanism that incorporates a kind of error correction
Okay.
into the memory updates. It helps the model learn more effectively from its past experiences.
Okay.
And on PG19, the linear plus delta version achieved an even lower perplexity score of 9.67.
Ah, so it's like the model is constantly refining its understanding of the text as it goes along.
Precisely. It's learning from its mistakes and improving its predictions over time.
Right.
And these results were consistent across both data sets. On math, the Infini transformer also outperformed the baselines, achieving a perplexity of 2.24, beating the memorizing transformer's 2.26.
So longer sequences, consistent results, efficient memory usage. It seems like Infini-attention is ticking all the right boxes. Did they try pushing the model even further by training it on even longer sequences?
They did. They experimented with training on sequences up to a whopping 100,000 tokens long.
Wow.
And as you might expect, this additional training further boosted the Infini transformer's performance, particularly on the math dataset. Its perplexity score dropped to 2.21.
So the more it learns, the better it gets.
Exactly.
Makes sense. You mentioned earlier that Infini-attention develops these specialized attention heads during training.
Right.
Can you elaborate on that? How do these specialized heads kind of emerge?
That's one of the most fascinating aspects of this research.
Yeah.
It's not something that was explicitly programmed into the model.
Okay.
Instead, as the model trained on these massive data sets, certain attention heads naturally gravitated towards specific roles. Some became experts at handling the local context, focusing on relationships between words within a segment, while others specialized in retrieving relevant information from the long-term memory.
So like the model figures out its own optimal way to process information, kind of a division of labor within the AI.
That's a great way to put it. This self-organization seems to be a key factor in Infini-attention's ability to effectively balance the immediate details of a text with its broader understanding of the entire context.
Right.
And this leads to some pretty remarkable results, especially when you look at their experiments on a truly mind-boggling task.
Okay, you've got my attention. What did they throw at this model?
They tested Infini-attention on something called a passkey retrieval task. Imagine a random number, a passkey, hidden within a massive chunk of text, up to 1 million tokens long.
1 million tokens. That's like trying to find a needle in a digital haystack.
Exactly. It's an incredibly difficult task, especially for traditional LLMs.
Yeah.
But a 1 billion parameter LLM equipped with Infini-attention was able to successfully retrieve those passkeys with remarkable accuracy.
So it's not just remembering the recent past. It's maintaining a grasp of the entire context,
Right.
even when dealing with this crazy amount of information.
That's right.
And this ability to capture long-range dependencies is crucial for tasks that require a deep understanding of the entire narrative, like summarizing a book, which was their next challenge.
Ah, yes, the Booksum benchmark. Now that sounds like a real test for an LLM. Summarizing a whole book accurately is a tough task, even for a human.
It certainly is.
Yeah.
But the Infini-transformer rose to the challenge.
Okay.
They took an 8 billion parameter, LLM, upgraded it with Infini-attention, and set it loose on the Booksum dataset, which involves summarizing entire books.
So how did it do? Was it able to produce coherent summaries?
It did much more than that. It actually achieved a new state-of-the-art result on the Booksum benchmark, outperforming models specifically designed for summarization.
Wow. So it's not just a one-trick pony. Infini-attention can handle a variety of tasks involving long sequences from language modeling to retrieval to summarization.
Exactly. And the most encouraging part is that they observed a clear trend. The more text they fed the model during training, the better it performed on the book summarization task. So, more data, better results. That's a familiar theme in the world of AI. It seems like Infini-attention is capable of scaling to even longer and more complex texts. What else stood out to you about this research?
Well, one thing that really caught my eye was the inspiration behind the compressive memory system.
Oh, where did they get their inspiration?
It might surprise you to learn that they drew inspiration from models of the human brain.
Now that's fascinating. Are they suggesting that Infini-attention is mimicking how our brains work?
In a way, yes. They were particularly intrigued by how our brains form memories and recall information through associations. This led them to incorporate a type of associative memory matrix into their compressive memory system.
So it's not just about brute force computation. It's about understanding the fundamental principles of how we learn and remember. That's really cool.
It is. And this approach, this blend of neuroscience and cutting-edge deep learning could pave the way for even more powerful and brain-inspired AI systems in the future, systems that can process information more efficiently, adapt to new situations more readily, and perhaps even exhibit a deeper level of understanding.
Yeah, it really is amazing to think about, we might be on the verge of creating these AI systems that learn and remember more, like we do.
It is. It's a fascinating frontier, for sure. And this research on Infini-attention, I think it just highlights how much potential there is when we combine insights from different fields, like neuroscience and computer science.
Absolutely. We've covered a lot of ground in this deep dive.
Yeah.
We've gone from those limitations of traditional LLMs to the intricacies of Infini-attention.
Right.
And its impressive performance on all these different tasks.
Yeah.
But I kind of want to bring it back to our listener for a moment.
Okay.
What's the key takeaway here?
Well,
Why should they be excited about Infini-attention and this whole idea of infinite context in AI?
I think the main takeaway is that we're witnessing this fundamental shift in what LLMs are capable of.
Okay.
For years, we've been constrained by those limits of fixed context windows.
Right.
But now Infini-attention is offering us this glimpse into a future where those limitations might become a thing of the past.
It's like we're opening a door to a whole new realm of possibilities.
Exactly. And this has the potential to revolutionize how we interact with information. Imagine LLMs that can just effortlessly analyze and synthesize information from massive data sets like scientific research papers, historical archives,
Wow.
legal documents, or even entire libraries.
Yeah, it'd be like having a research assistant with this superhuman ability to process and understand information.
Precisely. It could transform how we make decisions, how we conduct research, how we even learn new things. Imagine asking your LLM to summarize a complex historical event,
Right.
taking into account all the relevant social, political, and economic factors,
Wow.
or having it generate personalized learning materials that adapt to your unique learning style and pace.
That's a really compelling vision. And it seems like Infini-attention, with its focus on efficiency and its compatibility with, those existing AI architectures, could really be a key driver of this progress.
I think so. It's not just about creating bigger and faster models. It's about making them more meaningful and more useful for real-world applications. And Infini-attention seems to be a significant step in that direction.
Well, I'm definitely feeling inspired after this deep dive. It's clear that the future of LLMs is incredibly bright,
Yeah.
and I'm so eager to see what amazing advancements emerge in the coming years.
Me too. It's an exciting time to be working in this field. We're really pushing the boundaries of what AI can achieve, and who knows what incredible breakthroughs are waiting for us.
And on that note, I think it's time to wrap things up. So to our listener, we want to leave you with one final thought-provoking question. As we move towards this world where AI systems can grasp, seemingly infinite context, how might this technology impact your own field of interest? Could it revolutionize the way you work, the way you learn, or even the way you think? We encourage you to ponder those possibilities and join us again next time for another deep dive into the frontiers of knowledge.